Hello, everybody. Good morning, good afternoon, good evening. And today's talk is the Victorian theory of everything keeps getting ignored. So my sessions have been really anti-relativity sessions, complaining about Einstein's relativity. And one of the issues that tends to get ignored is that if you are opposed to Einstein's relativity, then there was already an existing unified theory of everything. And so if you think Einstein's relativity is wrong, you should then be saying, well, we should go back to the existing theory of everything, which was around at the time and is sometimes called the Victorian theory of everything. But that seems to get ignored a lot. The mainstream doesn't seem to want to bother talking about the Victorian theory of everything, and the people that think Einstein's relativity is wrong don't seem to then want to go back to talking about the existing theory which was around before Einstein, namely the Victorian theory of everything. So I'm going to go through that. First, I'm going to check that we're coming out all right on YouTube. Yep, we seem to be all right on YouTube. Hopefully everybody can hear me all right and there's no problems. So I'm just going to amble on about this through the slides. Unfortunately, I haven't really got a video with this. There are lots of videos about what I'm talking about, which is vortex theory, but I was unsure which one to share about it. So the people in the Chopin Natural Philosophy Society are just not going back to basics, that modern physics is based upon point particle theory. And so I'm going to look at that first. So it's prejudiced among many in CMPS, the Chopin Natural Philosophy Society, that don't accept mathematics is the language of physics and want to reject certain mathematics in favor of making something else up. I'll just get a glass of water. My voice is going. Okay, but the whole of modern basis of modern physics is point particles. So just have to deal with them. Einstein's theory of relativity, 1905, is a point particle theory. And that might become as a surprise to some people that Einstein was dealing with point particles. So we go into that now. So this is the official translation of Einstein's 1905 German paper of relativity into English. It should be common to most people that have been interested in Einstein's relativity to look at that English translation at one time or another. So the relevant quote from that paper is, "Let there be in motion in an electromagnetic field an electrically charged particle in the sequel called an electron for the law of motion which we assume as follows," so forth. And that's what the official paper is saying. But as this person, Arthur Miller, points out in his book, Special Theory of Relativity, that is a bad translation. So contrasting what's just quoted there with what he's saying. So the commonly used translation, if you note there, is contrasted with what Arthur Miller's translation is, and he says, let there be in motion in an electromagnetic field a point particle possessing the electric charge epsilon in the sequel. This electric charged particle is called an electron, and we assume for its laws of motion the following, and so forth. So highlighting the main difference, in the commonly used translation, the word particle is being used, but in Arthur Miller's translation, the word point particle is being used. So the commonly used translation omits the word point. This is the relevant German passage, and the relevant words are the first word translation to English as point shaped, and the other word translation to particle. And if you look in the German, so he's talking about a point shaped particle. And it's easier just to say point particle. So the commonly used translation has omitted the word point. And so if you're going back to Einstein in the German and paying more attention to it, then Einstein is talking about point particles. And that can get forgotten about when you're dealing with the English translation, the commonly used English translation, which is a bad translation. Einstein is dealing with a point particle theory that has been hidden in a bad translation. So the point particle theory was investigated a lot by this man, Boscovich. So a lot of the credit for the point particle theory goes to Boscovich. And another person who dealt with it was Kant. And so sometimes it's called the Kant-Boscovich theory. And this is the basis of modern physics, that you are dealing with point particles. So physics is a building process, at least as regards Einstein, because he was building upon what other people had said before him, namely about point particles. Galileo led to Newton, led to Boscovich, led to Einstein. Modern physics is built on point particle theory from the direction of Einstein. In the context of the point particle theory, there was a unified theory of physics, which can be referred to as the Victorian theory of everything. So this is a paper which is published in Centaurus, and it's dealing with the history of physics. And this by the historian here points out that there was a vortex atom being dealt with, and that was before Einstein came along, and that was the Victorian theory of everything. And that was the type of physics that Einstein was working from. So the idea is that these point particles swirl around, creating vortexes. Now, there was a split between Einstein with Bohr over quantum physics. And that split then became talked of as Einstein staying with classical physics and most everyone else going with quantum physics. And the classical physics would be the vortex atom, the Victorian theory of everything. So if you want to stay in classical physics context, that's where Einstein was, and have to point out where he'd gone wrong with that classical physics. I'm amazed at the people in CMPS, Japan Natural Philosophy Society, that don't recognise that and think abandoning Einstein is going back to classical physics. But actually, to go back to classical physics, you've got to give up on quantum physics, the same as what Einstein did. Next. And the tradition of physics is the Victorian theory of everything. Everything in classical physics, from Galileo and Kepler, Newton, Boscovich, and so forth, was leading to the Victorian theory of everything, which was the vortex atom. And mathematically, it gets very complicated. So people who think the math should be simpler than the complicated maths of the mainstream, they're mistaken. If you're staying with classical physics, the mathematics does get complicated. Ideally, we should stop wasting time with those who don't recognise that modern physics is highly mathematical, with point particle theory being classical physics. And as a reminder, CMPS stroke MPA, what it used to be known as Natural Philosophy Alliance, was based on neo-Newtonians. And these are people who were at the formation of our society were advocating the return to Newtonian physics. So this is where it is. So, hold on a minute, I'll look. Yeah, that's better. These slides are coming out better on YouTube than what they're appearing here. So it happened that our group was at this event, a physics conference, and after this physics conference, NPA, Natural Philosophy Alliance, was formed. That group then later became called the John Chappell Natural Philosophy Society. And so this is the picture of the people at that conference. The people there are being referred to as neo-Newtonians, the ones that are dissenting against modern physics. They're advocating the return to Newtonian physics. And as I've just pointed out, Newtonian physics had got to the stage of becoming the Victorian theory of everything, based on the vortex atom. So this is an interesting person. It's Jim Carter, and he likes playing around with vortexes. And he formed these spoke rings, and these spoke rings are supposed to be an allegory to what an atom is doing. So in this article, it does mention Jim Carter as being a dissident with his theory of vortexes. And this lady, Margaret Verheim, does try to debunk him. And she points out that this is what she says, and I'll have to get closer to the screen to read this. She says it's wrong that men like Carter are frozen out of mainstream science. Wouldn't the world be better if, in the evoked phrase of Mao, we let 100 flowers blossom and grant these men some recognition? ? So even though Wertheim, who's a sort of like a believer in the mainstream and a popular science writer, even though she thinks Jim Carter with his idea of vortices is on the wrong track, she thinks it's interesting what he says. In order to show that Carter's theory of circulons, that's what he's calling vortices, I think, he believes undergird all matter and energy is worth scientists' regard. She narrates the theory of vortex atoms proposed by Tate and Thomson, later known as Lord Kelvin. So in the 19th century, that's what came about. It was the theory of everything based upon vortices. And so she recognises that. So Jim Carter, as a dissident, was dealing with the Victorian theory of everything, but I don't think he got into enough mathematical details about it. As I'll point out, the mathematics can get complicated. I'll get my glasses back on again. The mathematics for classical physics comes from Euclidean geometry, with the realization that don't need the fifth postulate. That's the parallel postulate, and that then leads on to Euclidean geometry. The math just gets harder as further develop it. just have to accept that. It's no use inventing different mathematics which has no connection to that, because it's not the mathematics that classical physics is based upon. So classical physics, you're going from Galileo to Newton and so forth, it's based upon the mathematics, Euclidean geometry. Even if you're going to abandon the fifth postulate, the Euclidean geometry is the starting point for it. And Euclidean geometry starts with the basic idea of a point. From the point, you build everything else up. And that's why the physics adopted that mathematics. So Einstein is part of that classical physics, as I pointed out. He's talking about point particles, even though that gets lost in a bad translation. So there's no point ignoring him. Instead, have to point out what is wrong with Einstein. And the problem seems to me that Einstein's two postulates that he gives aren't unclear as to what they're supposed to mean. So you've got the postulate of relativity principle. It's unclear what Einstein means by that. It gets changed a lot by different people when they start using it. And then Einstein's postulate that the speed of light is constant, that sort of like, that doesn't not really clear what's that supposed to mean. So that's basically it. If you want to say Einstein is wrong and go back to classical physics, well, Einstein is part of classical physics, and the classical physics had a unified theory. And everybody who's in CMPS who starts talking about their own personal pet theory, they're just going off onto a diversion. Really, you need to get back to this basic idea that classical physics is based upon point particles and so forth. So thank you for that. And now, unfortunately, I haven't got a video, but there are lots of videos on YouTube dealing with vortices. So I will now open it up to discussion. Thank you. Enter that. Remove. Oh. Remove. So unfortunately that's a bit small, but this example that is Wikipedia does talk about the vortex theory of atoms. So anybody want to put their hand up? And I think Dennis has put his hand up. All right. Dennis. Hi.
Yes, the Bergman-Allen electron modeling theory, which has been extended to modeling protons and neutrons as an electron and a proton in a certain close position, based on the point particle idea, but each of the proton and the electron and the positron and the negative proton are all modeled as spinning charge, either positive or negative, depending on the particle. It goes in a torus, a toroid, if you like. So all the basic particles, the electron, the proton, the positron, and the negative proton, are all modeled as toruses, spinning rings of charge. And this has the advantage that the particles are stable. Column forces do not force them apart, because in the case of a torus, the magnetic field circles each part of the torus, and as a result, it pinches the charge inward, and just enough pinch to counteract the column forces, which are outward. And as I say, a neutron can be modeled with, as a proton and electron in a certain close position. Now, this has all been carried out mathematically according to the point particle idea in physics. But it is a vortex theory in the same sense as man Carter you mentioned, because the electron is a torus of charge, the proton is a torus of charge, and the positron is a torus of charge, and the negative proton is a torus of charge.
Yeah.
So it isn't a case where you have to either take the vortex theory or you have to take the point particle model. The two can be merged. Each of these rings of spinning rings of charge, you can take points in them and integrate around them and get results like they're stable. They're not going to blow up due to strong column forces because the magnetic pinch forces hold them in. Exactly, they're in equilibrium. And this idea was not my idea; it was Dave Bergman's idea. But he wasn't a mathematician like I am, and so he couldn't carry out the mathematization of these elementary particles, the four elementary particles, the positron, the electron, the proton, and the negative proton. I had to do that for him, but the idea is his. And also Bill Lucas talks about spinning rings of charge too. And you can see this on ResearchGate under my name on my page on ResearchGate or on academia.edu. I have an account there too. So the idea that you either have to take the Victorian theory of everything or else the point particle model is wrong. The two go together hand in hand if you handle the mathematics right, which I was able to do. And
I was thinking of vortexes as point particles swirling around.
yeah, well, the point particle is an idealization.
Yeah.
If you have a spinning ring of charge and you want to analyze it according to the point particle theory, you take little points, little tiny points inside the charge ring of charge, and then you integrate all over the torus. You integrate these points of charge. Yeah. So this idea that you have to take one or the other is wrong. You have to take them both. At least we think so.
Yeah.
Dave unfortunately passed away, but I still continue on.
If you go back to the Victorian theory, everything, it was still a theory that was being developed at the time.
Yeah.
And they were trying to bring the idea of point particles in with the idea of vortices. And they're coming up.
And it works. I've done that, and it works.
So if you saw, Einstein was working on classical physics, and so he ideally should be working on the Victorian theory of everything. And if you say, well, things that Einstein's saying about his postulates of so forth are wrong, well, going back to classical physics before him, then you have this idea of the vortex theory. Yeah.
Yes,
it's sort of like when I'm doing these anti-relativity talks, it's sort of like, well, the suggestion is then what theory is there? Well, if Einstein's wrong, you just go back to how physics was before, where they had the unified theory which they were working upon, and sort of like we don't seem to agree upon that. We don't that particular issue. Instead, people say, "Well, Einstein's wrong. Let's go then invent our own personal theory about everything." So, 100 people saying Einstein's wrong, and you get 100 different theories, and they don't seem to agree that you should be talking about the vortex theory.
Yes.
If you abandon an Einstein.
Vortex theory for elementary particles,
Yeah,
in my
and and
opinion, is
and,
the way to
unfortunately
go.
the mathematics gets complicated because I was
Yeah, it
talking.
does. It does get complicated. We had to use
Yeah,
Mathematica to solve some equations. We couldn't do it by hand.
yeah.
But
I've
that's
talked.
life,
Yeah,
That's the way it is.
yeah. I've talked to people about Bill Lucas mathematics, and there seems to be a lot of things in what Bill's mathematics he needs clarifying because he seems to be dealing with vectors in a very strange way. So I've got this book on it, and it's sort of like he needs to clarify a lot more before people can understand why is he doing mathematics in such a different way. But our group, we don't seem to be, in my view, getting anywhere that we can all agree that Einstein wrong. Therefore, go back to physics before Einstein. And we
No,
seem to have
well,
that.
because mainstream physics is entrenched. It's they've made up their mind. They've got their physical
Yeah,
paradigms, and they're going to stick with them come hell or high water.
yeah. That's the
And
mainstream.
and,
When,
uh,
when
and so the only way that you can convince people you ought to go back to vortex models for the four elementary particles is to have some success commercially.
yeah,
Everything follows money.
yeah,
So, so you've got to get some people to use that and then model atoms, which are made up of protons, electrons, and neutrons, and then model molecules, which are made up of atoms, and then get some kind of a success like the Schrodinger wave equation was used to model especially organic molecules.
yeah,
And so that success made Schrodinger impossible to ignore for the mainstream. But you have to. We think that although Schrodinger's methods gave a lot of good results, Dave Bergman and I felt that our theory would give even better results.
yeah,
But somebody has to do all this, and it's hard to find people because the mainstream, when they find out that you're not one of them,
yeah,
they they come at you with you're going against settled science.
yeah,
Sort of like Dr. Fauci. That's what when people didn't want to get the vaccine, which I did not get, he came on and said, I am science. If you're against me, you're against science. And of course, then the implication being that you should at least lose your job if you're against him
yeah,
and settled science. But of course, I didn't have a job. I was retired.
yeah,
But that's the way the mainstream handles things now. They get rid of you if they
yeah,
can, and they don't refute you. They get rid of you.
yeah. But the mainstream, they've seemed to abandon the vortex theory. They're sort of
Yes,
like not looking
except
at it.
yeah,
And,
yeah,
and we as dissidents, when we don't agree with Einstein, the dissidents who don't agree with Einstein, we should be saying the replacement is the vortex theory. And we then are sort of like more unified on saying what the replacement is. But at the moment, we don't really have a replacement. We just got lots of numerous different ideas of different theories.
Well, there's not a universally accepted one. No.
No, if we dissidents could sort of like agree what theory we want to replace Einstein by as being vortex theory, we've then
Yeah.
got something to say
Here's a
to
picture of.
demonstrate.
Here's
Yeah,
a picture.
it doesn't come up very well. I can't see it very well.
Can't you see it? spinning ring of charge, and then the magnetic field, and if anyone who wants a copy of this, just send me an email at Allen, ALLENS 10, in other words 10, ALLENS 10 at sbcglobal.net, and I'll send you a copy of this article.
Does it go back to the very basics of how you're forming these vortices?
Yeah, it goes back to Coulomb's law and Lorentz law of force, and the Bios and Savart law, and so on.
Okay. So if we can, or us distance agree that we've got roughly a theory to replace Einstein with, then that would be something the mainstream might pay more attention to.
No, it's got to be a commercial success because everything follows money.
Yeah, that's been
no matter how good and how well written up, and they just ignore it. And if you press them, they become hostile and attack.
Okay. I hope that that's not quite the case for everybody, that they're only driven by money. Okay, thank you. Cheers. So I try somebody to get you finished up.
Yes.
Bye. Let's see who else has got their hand up. Thank you. Yeah. Right. Anybody else want to put their hand up? No. Okay. No. Vladimir. No. Nick. No. No. Nobody else in the green. Nobody else in the green room put their hand. Harry might come in. Do you want to talk, Harry? No. Nobody's got their hand up, so I go through the comments. Let's see. So that's a question what a vortex is. Well, I'm treating as just point particles swirling around. You're going back to classical physics, and really it's based upon Euclidean geometry. You've got points and point particles, and then you went on to the idea of vortices, where I think of the point particles as swirling around. So it says torus model is easily disproven simply by measuring the energy of particle using a calorimeter and seeing that it doesn't have enough degrees of freedom. But toruses are donut, and when they talk of electron spin, they say it's got to be rotated by 720 degrees to get back to its original position, rather than 360 degrees. So I don't see what you're supposed to mean by that. So it's not extra energy when you measure the energy of a particle. Well, I think the problem of energy is a problem. You've got kinetic energy, and you've got kinetic energy, and you've got potential energy, and various other forms of energy. So how do all these sort of different types of energy connect to each other? I don't think the mainstream really properly explains that. Yeah. Yeah, cosmology is breaking, so is physics. Yeah, the ideas of physics come from experiment, and then you get theories, and those theories you then apply to cosmology, and cosmology is more speculative. So yeah, it's all broken. And I think there's a talk tonight. Well, there's a talk tomorrow on cosmology on Zoom. So next one. So next. Yeah, so the physics model built on the Sapphire project. Yeah, that's the electric universe. Yeah, I don't think there's anything interesting in the comments. There's a private chat. Let's have a look there. I've got private chat, and I don't think I have the ability to put them on script. Oh well. Oh well. Go back. Comments. Okay. 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 Anybody else putting their hand up? No. No. Don't think so. I'll get rid of that comment. Where is it? Physics model. Physics model. I can go into this one. Show. A torus field is a Z pinch, bro. So that's referring to somebody else. Any more hands up? I think there isn't going to be. Oh, yes, Vladimir. Out of state. Yes. Hello, Vladimir. Thank you.
Hello, Roger. Thank you so much for interesting discussion about the correlation between classical physics and quantum physics.
Yeah.
No doubt that Einstein was classical physicist. That's why his imaginations were around classical physics only, because general relativity, special relativity, it's a classical physics. What about classical physicists? They started quantum physics more than 100 years ago, as you know. Planetary models, this model, it doesn't matter. They're trying to explain quantum objects with classical notions. Unfortunately, it was the beginning of the story. 100 years passed, and we should do something about it. This new Victorian theory of everything, it's a classical physics, no doubts about it, because vortex, all these notions, what we have right now, and you introduced in this model, there are classical notions. Quantum physics based on these point particles, not point particles, nobody knows what they are. Because even the size and the time we can introduce only in classical physics when we have already the notion medium. It's an ensemble of quantum objects, and we don't know what they are. That's why all these equations of quantum physics based on notions, space, time, they're absolutely wrong. There is no such notions to work with. This, as for me, it seems to me the most important part of this quantum physics. It's some particles, I don't know what they are, and they have only four momenta only, energy, momentum, that's it, what they have, and so on and so on. Quantum physics, you can develop only based on mathematics only. And the best way to go with operators and finite mathematics, as my friend Felix Lev done in his life, He proposed totally new basis for quantum physics without all these stories, planetary and so on and so models. There is only mathematics, and there are some only operators, and there is only finite mathematics. That's it. There is nothing to do about it. We are not we are not quantum objects. We cannot see, like we cannot see fourth dimension. The same story with these quantum objects. We are not in this business. We are classical objects, and we can do only classical physics. That's why for me, I didn't miss this point in my model. No, I'm only telling the truth. I don't know what they are. What I can tell about them only for momenta. That's it. All the rest, it's imaginations, it's a classical notions introduced for quantum objects. Wrong. That's why even this model, the other model, it doesn't matter for me. Quantum physics right now in problems too. It's not only a revolution right now in classical physics, in quantum physics too. If you will take a look on their sites, and I'm watching them, I'm looking at them, they are the same story with them. They don't know what to do about it. They don't know how to change something because it doesn't work. That's why this vortex, not vortex, it's a classical physics. Don't try to apply classical notions to quantum objects. That's it. It's simple like this. And don't waste your time and our time on quantum objects because we know nothing about it. And even this, discussion, argument in, for, and against, it doesn't matter because we don't know. Simple like this. Thank you so much.
Thank you. Okay, you okay?
Yes, I'm okay. Thank you so much. Because, I'm tired. Classical physics is ensemble of quantum objects. When you have your ensemble, then you can do whatever you want with classical objects, with classical physics, and so on and so on. This is what is our real truth, and this is our experiments. Everything what we're doing, it's experiments of classical physics. We can confirm only classical physics. That's it, simple like this. Many times I told about them, and unfortunately, you didn't take my main idea, the difference between quantum physics and classical physics. The size is less than 10 to the minus 14 meters. We cannot even discuss. And this size, 10 to the minus 14 meters, I calculated based on experimental results over 100 years ago. Take a look at my papers and you will find out why we cannot go lower. Forget it. Classical physics, it's only from 10 to the minus 14 plus, not minus size of any object. And unfortunately, and it's so good that we can talk about some particles, we can talk about the energy of them, about something else, but don't ask about the forms, the size, this vortex, planetary, even Coulomb law for atoms. No, it's a bullshit. No, but it was the beginning. I'm not blaming these genius people. They had no idea. They started something principle in you. And after 100 years to blame them for they've done something wrong, it's not right. I'm sorry. I have a respect to all of them because they were beginner. They knew nothing. And after 100 years, what we propose? Nothing. This is my main point. To blame somebody, this our physics right now. But propose something new. Propose something new. Nothing new. Sorry for my emotions, but I'm tired already of this, mixture. It's not physics. Physics means it should be very strict the definitions. This is a classical physics, this is a quantum object. This is this numbers, this numbers, and that's it. Let's stop talking about even quantum physics. We know nothing about it. Sorry.
Yeah. Okay. 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 People have proposed lots of new things, and say 100 people, and they all propose their own different theories. So I was just.
You're right. Hundreds of papers, money, all these issues. It's okay. But if we are physicists, we should talk in physical language, not in money language. You see what I mean? That's why people, they are following old-fashioned, like Big Bang model, like quantum objects and all this stuff, models, and have their grants, they have their money, and so on and so on.
Yeah.
We should stop it. We should do something about physics. At least in our society, we are dissidents, if I remember correct our names. That's why
Yeah.
let's talk about something new. Something new, please. If you have something in your mind, share with us your ideas. I will be more
Well,
than happy to talk about your
I,
ideas, not about somebody and
I, I,
blame
was-
him for doing
I was
something
trying,
100 years ago
yeah,
wrong.
I was trying to point out that this group was founded upon the Neo-Newtonian, so it's was a proposal to go back to Newtonian physics.
But
I'm
Newtonian
trying,
physics is classical physics. It's
yeah, classical
classical.
physics. There
That's
was
why
proposals,
please don't move this classical
yeah,
physics inside of quantum physics. Quantum physics, it should be based on a finite mathematics. And he used, my friend Felix Lev, he used only operators. That's it. It's
yeah,
mathematics. Yes, we are not good in mathematics. We cannot evaluate what he's doing, and it's
yeah,
correct. But this is the right approach only. Don't ask the question. Even this, initiators of quantum physics, they told me we are doing some mathematical calculations. Don't ask us what we are doing. Compare results, what we have got, with your experiments. That's it. Simple like
yeah,
this. They didn't insist on value of their mathematics. No, it's some instrument to get some result. And then this result we can compare with something. Okay, at least it was fair approach to quantum physics.
yeah,
At least it works. We have something right now based on quantum physics, and we're lucky that we have something in our hands. You know what I mean? Lucky.
okay. Thank you. Thank you. I think Dennis has got his hand up now. Sorry, Dennis.
Okay.
When I say that we have a model of the electron, the proton, the neutron, the positron, and the negative proton, I don't mean to say that that's what they are. I just say that's it. We can model them that way. And to justify this, we have to use results, as Vladimir said. We can't justify them because they're beautiful mathematical constructions. We have to justify them on results about atoms. For example, atoms are made up of protons, electrons, and neutrons. So we can model atoms, since we modeled protons, electrons, and neutrons as spinning rings of charge. We can model atoms and then we can model molecules. Now, if those models tell us a lot about molecules, for example, like the Schrodinger wave equation does, which is solved by a computer for molecules to just find out what the bonding angles are and whatnot. If we can do even better than that, then that gives some credence to our model. But we never say that our model is what these particles are. Our model is to see if we can get results in chemistry, for example. And if we can, then our model should be adopted if it gets better results than the Schrodinger wave equation, for example. And if not, then our model should be forgotten. But this idea that Vladimir is saying that we're going too deeply, we're imagining what we think atoms and so on are, no, we're just modeling them. We have no idea what they actually are.
Okay. Yeah.
You're right. We don't know where we are with them. And that's it. Planetary models or vortex models, whatever. It doesn't matter. Because don't apply notions of classical physics to quantum objects. It's mathematics only. It's my understanding what is going on. You cannot even use your wave equation immediately because you have immediately some space and time. There is no space and time in quantum physics. Forget it.
Well,
That's why it's only mathematics, and what is important should be operators only, without any space and time, and it should be finite mathematics. As many times I told about my friend, he's trying for 20 plus years to introduce his approach to quantum physics without any success because it's very difficult to do something with our contemporary physics. We're so high scientists that we cannot go around them.
yes, the contemporary physics is mixed up. There's no question about that. But if you can use classical physics to model basic particles, proton, electron, neutron, negative proton, and positron, and you can use that model because they're electromagnetic constructs. So you can use electromagnetic theory to predict how molecules, for example, will bond together and so on. Then it's hard for me to understand how Vladimir can, in a case like this, if Vladimir can say, well, no, I don't think we ought to do that. I mean, if it's giving good results, then why, that's the name of the game, it seems.
You're right. Let me tell you one more time. It's very important me to say you. Electromagnetic waves, all this stuff, it's Maxwell equations. In Maxwell equations, there is no even notion, charge, energy. There are only energy density and energy flux density. That's it. You see, even charge we invented. There is no such a notion in Maxwell equations. That's why we are trying to use something for something else. They didn't suppose these equations to apply for any quantum objects. We invented this charge, we invented energy, invented all these notions for us to understand something with quantum objects. That's it. And I'm so happy that we're lucky we can do something. We can do even nuclear bombs and all this stuff, guys, because of quantum physics. It's a good luck, and the genius people, they guess something of the mother nature without knowing what is the reality is with quantum objects. It's unbelievable for me what they've done. But don't overreact. Don't put all these, classical notions inside of these quantum objects. Forget about it. It doesn't work. One of the bullshits of Big Bang model, photon during his life, he's flying to Earth, increase his wavelengths. It's unbelievable for one photon to introduce wavelengths that spreading out during the performance during their time from star to Earth. It's unbelievable. And based on this notion, they explain microwave background radiation. It's unbelievable. People, they forgot even basis of physics. Microwave background radiation must be in thermodynamic equilibrium with some body. In Big Bang model, there is no body, and that's it. But there is a big microwave, and this is one of their successes. It's unbelievable. Look at that. How we mix all our notions of physics, classical with quantum, and we introduce so magic behavior of photons. Photons, they don't have wavelengths. Forget it. That's why, I'm tired about this. We must clean up our physics, guys. If we're talking about classical physics, let's talk about classical physics. If we're talking about quantum physics, let's talk about the mathematics. This your calculations. That's it. Without any following, words about vortex, not vortex. I don't know. I do like more planetary model, but it's only I do like, not it's real. It's not. That's why please.
As I said,
Well,
we do not.
we're talking about mixture. Let's talk about it. Sorry
we
for
do
my
not claim
emotion.
that
Because for
electrons
many
are.
years, I know this, and I'm tired already about all these mixtures. People, they forgot, genius people in the past, they forgot basis of classical physics, and they're trying to invent something, to put something magic in quantum objects. It's unbelievable.
Uh, we do not, I repeat, we do not say that electrons have spinning rings of charge. We only say that we can, if we model them that way, we get some interesting results, and hopefully even more as time goes on, to the point where we'll replace the Schrodinger wave equation for uh, for telling us how atoms bind together and form molecules, which the Schrodinger wave equation is very successful, but we hope to even be more successful because there are some cases where the wave equation of Schrodinger gives the wrong answer. And but if we're getting good results, and some of the results that Bill Lucas has got in a similar theory are just amazing, then why criticize? Shouldn't good results be the ultimate thing to strive for? As far as we admit, we're never going to know what an electron actually is, or a proton, but we know some of its properties, and so that suggests a model, which then we hope will give good results in chemistry, for example. and physics and so on. Isn't success in this area the thing that we should ultimately search for, rather than principles like we've got to forget all about this, or we got to forget all about that? Let's each go our own way and see the results that we get at the end of the line.
You're right. You're right. Take a look at the results. That's it. And on your way to your results, you can use any mathematics. If you are talking about this wave equation, all this stuff, without any meaning, like a mathematics only, it's okay. Don't put any physical meaning in the value of this wave equation or something else. You see what I mean? Mathematically, you can do whatever you want. If you have some results and it corresponds to experimental results of our life, it's okay. But don't talk about size, vortex, or something inside planetary, inside of any atom, any particle. When the people, they're talking about the size of proton with accuracy 10 to the minus 18, 20 meters, and so on and so on. It's unbelievable. It's just unbelievable. It's only, dreams. It's only some kind of calculations. Don't overreact on it. Forget it. Forget it. This is exactly my point. You can apply any mathematics right now, what we have. You can see some results, and then you go, oh, my mathematics is better because I have got better results than somebody else. Okay, this I do understand. But don't go inside of these mathematical equations and try to put some physical meaning for them. That's it, simple like this. There is no choice. It's good that they're doing something and they have some results. It's great. It's just great. But for 100 people, nobody proposed anything new. My friend, he proposed something new. Nobody wants to accept it. It's good, as usually. Nobody wants to accept something. Everybody has what he has. And especially, if you have your grants, students, and all this stuff, you don't want to do any changes in your life. I mean, about professors of university. You don't want them. That's it. Simple like this.
No, the professors at universities want to retain the basic paradigms of physics, and so they ignore people who go off the plantation, so to speak. But if you become adamant and you irritate them past a certain point, then they'll attack, and That's why change is so difficult to get in physics. There's an old saying that isn't new to me. It's an old saying that physics advances one physicist's death at a time.
Okay, okay. I told already everything. What I want to tell to Roger right now. Roger, please take care about something new we have in our life. Dissidence means they propose something new from classical point of view for us. If you will find something interesting, let's talk, let's discuss what is good, what is bad, and so on and so on. Let's stop blaming some genius people 100 years ago. They've done their mistakes, and on their mistakes, we live already 100 years. It's good for us. At least we have something. But let's talk about something new, like I'm trying to do myself. I introduced for 8 presentations my model. It's only part of it. I've done much more for 24 years, guys. That's why it's okay. I tried to put in any presentation as much as I could because I wanted to have a curiosity of you to find out what is wrong, what is good, and what are the good questions to me, and so on and so on. That's why it was my intention to divide with you something new. Please put more attention right now to physics of dissidence, different dissidence maybe, with some new ideas for now, not 100 years ago. For now, maybe we'll find some solution, not only with my model, but with somebody else. We do something, some correlation, some correct connection,
So,
something.
from a historical point of view, there are ideas which get discarded. Science progresses, and there are ideas that get discarded, and then decades or centuries later, uh, science then goes back to these old ideas. The most famous example is the Copernican revolution, where the theory was that the Earth went around the sun, and that theory goes back thousands of years before Copernicus, and so Copernicus was suddenly reinstating an old idea. So science does go back to old ideas.
It does matter, whatever it is, something new. Even
Yeah,
about
like,
our egos,
it's
we're
not
not
it's not
so.
always it's not always something new. It's sometimes just going back to old ideas again. So
Oh, it's good. You know how many discoveries I've done with great physicists, 200 years, 300 years, we forgot about them. This is the
yeah,
main my point. I didn't use all my fresh idea. On the contrary, I used all the missed ideas in the history of classical physics. Sorry, man. It's exactly what we need to do. We must recover these genius people. They were before all these classical physicists right now. They are not classical. They're high value, high respect, and so on and so on. That's why I'm not blaming anybody. I'm blaming only for blaming somebody in the history and forgetting about these very great scientists, genius people, and we forgot about them. How many of them I opened, discovered for you guys in my presentations? We didn't know. I didn't know about them, and I had my highest level physical educations in Moscow. That's why. And nevertheless, I didn't know anything about them. It's it's a great pity for me that we forgot history. We don't know. We did forget what we don't know. We don't know history of physics. We miss so many great physicists, and let's name them with their ideas without blaming them. Maybe it's not right, maybe something else, but we should recover physics from all this mess what we have right now.
okay, okay,
Okay, thank you so much for your patience, guys. But
yeah,
it's the right time for me one more time to tell my understanding of physics. My great pity is that we forgot about great guys and we are following all these obsolete theories, obsolete, and we don't propose anything new. It's wrong. We have so many advantages, experimental advantages in cosmology, astrophysics, and so on and so on. And how we can use them? We are trying to accommodate them, to push them into the existing Big Bang model. That's it, simple like this. More results, more parameters, 20 parameters, 30 parameters, trying to explain all of them. No, it's absolutely wrong way to go. That's why, please, let's concentrate our society on great physicists. Please take a look on the history and don't blame them. On the contrary, say them tribute. Oh my goodness, how good they were, how great ideas they proposed. Why we forgot about them? This is exactly my curiosity all my last 24 years.
Thank you. Okay.
Okay, thank you so much for this discussion. Please, it's a great discussion. Let's continue these discussions. You know what? Harry, he opened right now Zoom conferences. It's a discussion of some ideas, some notions, and so on and so on. Let's go with not presentations. Let's go with some discussions. What we think about this. It's a good example, by the way, you have got today. You have some ideas, something new against the existing physics. And we're discussing right now with Dennis what we think about it. It's a good example of what should be done in our society. I'm a member of my society, and I am in favor of to do something about the value of our society, like a physical society, not something about physics. Okay, thank you so much for understanding of my emotions and my understanding where we are right now.
Yeah, thank you. Bye. Bye then.
Bye.
Yes. Bye. Okay, Dennis, if you got any more to say.
Well, I understand that a lot of the old ideas in physics might have some merit.
Yeah.
And that just because they're old ideas, they shouldn't necessarily be considered to be crackpot ideas. But there are some old ideas that aren't too good. Like, for example, the phlogiston here theory of heat. That's been, for a long time, that held sway, but now it's been, 100 years ago at least, it's been disproven experimentally. So you have to be careful what old ideas you want to use. Some are not; they're old and they're bad, and some are old and some are good. But just to say we ought to go back and reuse all the old ideas, I don't think that's. I think that's a little.
Yeah.
I don't know the right word, but I can't agree with that.
Okay. Yeah. So the way I look at physics now, it's sort of like sometimes they discard ideas, and sometimes they go with an idea, but they keep amending it. So.
Yeah.
So even with the theory of calories, if they stuck with it, despite the experimental evidence, it would just been modified a bit, I think. But that's I look at the history of it, and it's sort of like, well, it's just a bit of a mess, really. And in the sense of Einstein, I was trying to point out, classical physics was really the vortex theory come the end, before Einstein came along. So if you're getting rid of Einstein, you're then back to the vortex theory. And if you want to say, the vortex theory is wrong, well, then you're going back even further. And if
the vortex theory seems to have been a half good idea, because only the four elementary particles plus the neutron as a proton and electron in a certain close position can be modeled as far as we can tell anyway, as spinning rings of charge, either positive charge or negative charge. Depending, for an electron, it would be negative charge. For a proton, it would be spinning ring of positive charge. But so the atoms themselves aren't spinning rings, but the basic particles that make them up are protons, electrons, and neutrons. With a neutron being a proton ring and a spinning ring and an electron spinning ring, one inside the other, since a proton is much smaller than the electron, although much more massive. So it's the neutron is modeled as a spinning ring of positive charge inside a spinning, and then around that, but farther out, the spinning ring of negative charge, which is the electron. So that would be a neutron. And this way, you don't need a neutrino because the extra energy is because the two rings of charge mutually spin pump each other. They, according to Ampere's original law, they tend to amplify each other. And so you get slightly more energy, which they then, since they don't know what to do with it, they postulate a particle called the neutrino, which has no charge and extremely small mass.
Yeah.
And if you multiply it by c squared equals mc squared, then you get a small amount of energy, which they then assign to the neutrino. Whereas it's known, for example, David D. Hilster pointed out that the deeper you go into the Earth to measure neutrino flux, the less neutrinos you find. Whereas, according to theory, they should go right through the Earth without hardly any problems. So the neutrino is just another postulated thing that doesn't really exist as far as we're concerned.
I thought the neutrino was that a large number of them can go through the Earth, but some do interact.
I know, but because of that fact, the deeper you go into Earth and into salt mines, for example, you shouldn't get really substantially less neutrino detections because they most of them go right on through and aren't even held back, or there's no collision. But that's not the way, because experimentally, the deeper you go, the substantially less neutrino detections, which is, so the theory is contradicted by the experiment.
Okay.
And David D. Hilster was one who pointed this out, certainly not me.
Okay. Yeah, well, there may be different types of neutrino. Anyway. Okay.
Oh, yeah, they've got a whole raft of, I don't know, it's discouraging.
Okay, that's it. Thank you.
You're welcome.
Thank you. Cheers. Nice. So, goodbye. Where can we go? We move. Right. Okay. Thank you. Cheers. Anybody else going to hold their hand up? No. Yeah. And it's Harry. Yes, Harry at the stage. Hello, Harry. Hi. Thank you.
Well, your question has a simple. You're asking why is the Victorian theory of everything keeps getting ignored, right? That's your theory, your thesis of this presentation, and the answer is because they don't teach the history of science in school.
Yeah.
So that's a simple answer. I mean, nothing really mysterious about that.
I've gone to lots of sort of like lessons where they teach relativity. It's sort of like, you ask questions. Why don't they teach about Lorentz's theory when they're talking about things? And the answer is, well, they're being paid to teach relativity theory. They're not being paid to teach other theories. So,
that goes to the silo of science theory that Bill Lucas has talked about, where all these different disciplines of science have their own silo, and they don't talk to each other, and they don't integrate their ideas together. So the chemists have one idea, electrical engineers have another idea, physicists have another idea, and they don't talk to each other. And none of these ideas are actually coordinated and make sense because they're disparate paradigms that don't really relate to each other. So you have all these different science disciplines, and they're not correlated. I mean, and I think what Vladimir was pointing out, he was saying that, you know, quantum physics, people who believe in quantum physics can't talk to people who do classical physics. Okay, because their concepts are inconsistent. So people are taught mathematics, and the mathematics to be used in their particular discipline, but they're not taught science as in general. Now, there are people who deal with this in the philosophy of science who try to correlate the philosophy of, say, for instance, physics, and try to basically put it together to make sense along with the historians of science. But these people are in a minority, and it was only in the about 1950 that they actually started teaching the history and philosophy of science in schools. And Herbert Dingle was one of the first professors of history and philosophy of science at I forget which university it was in England. And of course, you know, they pushed him out of the physics profession because he didn't agree with a lot of the things they were teaching in physics. So he became a historian and philosopher of science, which, you know, kudos for him. So the answer to your question is science is physics, in particular, is mathematics. It's not really physics. So you have to ask your question, what is it that's physics about physics today? Okay, that's really the question you should be asking. What is physical about physics? Now, we had a couple examples. We had business of the neutrino. That's a theoretical object. The neutrino is a theoretical object derived from theory, and then somebody does some experiments, and they say, oh, we discovered this neutrino that we were predicting, so therefore the neutrino exists. And then somebody else comes along, like, for instance, David de Hilster got his ideas from, I can't remember, Corazzano, isn't that the guy? I think Corazzano, and I'm not sure I'm pronouncing it correctly, who is, David apparently met him and knew him, and he objected to the neutrino on theoretical grounds, and then David picked up that idea, and that's kind of where David gets that idea. So a guy comes along and he says, oh, you know, this theory doesn't really make a whole lot of sense. I have an alternative. They don't want to hear that because they've already blessed the neutrino as an existing thing in physics. Okay, we did an experiment, we found it. Then they do other experiments and they don't find it. You know, which is what he was talking about, the experiments that were done by.
Well, I think they're trying to.
I remember his name. They were in the salt mines, and they didn't discover the solar neutrinos that they were looking for. Oops! But they never discarded the idea or the theory of the neutrino, even though the observations didn't support that idea. So now then they invented a whole. So then they did what you said, which was they moved the goalpost. They invented. The new theory of neutrinos that they oscillate, and they change from one neutrino to another neutrino and do these neutrino oscillations. So they save the theory and the experiments. You know, this is what passes for science today. And okay, so we talked about that. I think what Vladimir is saying is we need people who basically do science, don't know anything about the history of science. They don't know anything about the philosophy of science because that's not what they're taught. They're taught mathematics. Mathematics is what when you go to a physics class, they don't teach you about physics. They teach you about mathematics. You get a textbook on physics, a physics textbook. They don't tell you about physics. They don't tell you about how, you know, Maxwell came up with his Maxwell's equations. They just give you Maxwell's equations. You know, it's all about mathematics. It's not about what the equations mean in terms of physics. because we don't need to know that, because all we need to know is mathematics. That's really what dissidents are objecting to, I think, is this taking over. It started with earlier than Einstein, but Einstein kind of, with his theory of relativity, he sort of, made it so that only mathematicians could understand what he was talking about. And so then to be a physicist, you had to be a mathematician. And then now I think it's that physicists aren't physicists, really. They're just mathematicians who deal in certain theories called physics. All right, I'm done with my spiel. I think Vladimir is trying to make some really valid points, and we ought to be paying close attention to what he's saying. The issue is, I think, is that English isn't his first language, and he says a lot of things, and it's kind of hard to understand exactly what he's saying. So we need to sort of listen more closely to what he's saying.
Okay, thank you. Things point out that when the physics people move the goalposts, they think that is progress when they're finding out something. So with the neutrinos, they thought they'd establish their existence, and then they do their experiments and then decide, oh, we need different types of neutrinos. The way they think that's progress, but really it's moving the goalposts.
Well, it's some guy published a paper that got past the guardians called referees. The paper passed the referee guardians, and so therefore became valid science because it got published in an important journal. Yeah. That's what passes for science today. Yeah. I did want to point out another example, and this goes way back, and that is this idea of displacement current in Maxwell's equations. And one of the issues, and this is a long-standing controversy in EM theory, nobody really knows what this displacement current thing is. Well, they made such a mess of explaining displacement current in the textbooks that if you go back to what really displacement current, what Maxwell thought he was talking about, it doesn't relate at all to what the textbooks are saying. Okay. I mean, the textbook, they just kept changing the textbooks to make it understandable to students, and eventually the idea of displacement current has nothing to do with what displacement current really is. You understand how that works?
Yeah, and moving goalposts.
Well, I don't know, it's moving the goalposts as much as the whole concept is completely different than what it started out to be, because they wanted to make the mathematics, the concept fit the mathematics. The concept fits the mathematics. So it's not what the concept really was, or what Maxwell really thought he was talking about. It's not what Maxwell thought he was talking about anymore. It's what the mathematicians wanted Maxwell to be talking about.
Yeah, that's moving goalposts.
Well, I wouldn't call it that. I think it's more or less they're confused. They've confused the issue. They don't know. And Vladimir brought up the concept of electric charge. Okay. That's another controversy in electromagnetic theory. What is electric charge? And of course, Ivor Catt came up and said, well, there's no such thing as electric charge, and based his ideas on Heaviside and, the people who were thinking, the fathers, as Vladimir would call these, the fathers of the science. And he started pointing out this to people, and they didn't want to hear it. The people in the physics community didn't want to hear a new concept of what electric charge is, because they didn't want to change the textbook. So we're stuck with this old, obsolete notion of electric charge rather than a new idea of what can be thought about in physics. But no, they don't want that. They want to hold on to the old ideas. And I suspect that that's a lot of people are. Okay. I'm done with my rant for today. Okay, we're going to have a discussion of cosmology tomorrow at 10. Yeah. And so I just want to remind people of that. If you're interested in talking about something different.
Yeah. Okay. You could put out a link in the comments do that for people. Yeah, please.
Well, you can send me an email if you want the links. I'm not going to put a link in the comments. I mean, it's way too much trouble for me to do that.
Okay.
Sorry.
Okay. Cheers. That's it. Bye then. Bye. Thank you. Okay. Right. Anybody else got their hand up? Yeah. I think that's it. Nobody else got their hand up in the green room. Great. So let's have a look at the other comments that's coming through. Oh. God, it goes back too far now, these comments. Okay. So this person seems to have written some things on vortex theory about annihilation of entropy in vortices, which should be interesting. Converted. Any points out where the article is? It's on ResearchGate, Academia, edu. So, so Shockwave says it's up to the individual to learn themselves. It's not the job of the university to teach it all, but just teach the mainstream. Yeah, well, from my experience, they don't tell you what they're missing out. They'll teach you what they think is important to teach you in science classes, and they won't say what they're missing out. Most physics departments offer a history of physics course, yeah. Well, I think people specialise as either being a physicist or a historian. So then it splits up by that. I don't know. So why ignored? I suppose it's on the question of why is the Victorian theory everything be ignored? So because newer models explain more observations, but what happens when a proposed model explains more observations? Question mark. I think the point of this, I was trying to point out as to why is the Victorian theory everything being ignored, when really it's classical physics, and that was what Einstein was working from. So when they're teaching relativity, which is when they're teaching classical physics of Einstein, they're not mentioning that he's working from a unified theory from the 19th century. They're just ignoring mentioning that. So, and I think they should mention it, but they decide to ignore that. And when they teach quantum physics, well, they've got the problem with the quantum physics is not merging properly with classical physics. So they ignoring it once again. They're sort of like ignoring the idea that from classical physics, they came up with this idea of vortices and all that, and they're not explaining how they get from that to quantum physics. So by ignoring things that leaving gaps in people's knowledge. So he says here, Harry is completely incorrect. So I don't know what he means by that. What part thing Harry is saying. So doesn't this Andrew says if the neutrino doesn't exist, the conservation of momentum doesn't exist. What? David Hill explains it's just a trick in the mathematics. It's not really a particle called the neutrino. It's just a mathematical fudge. So, but that's diverting onto a different topic. Going down, let's see, still loads more comments, but not relevant. Oh yeah, Dennis wants to say some more. So that's a minute. Because this one, as I remember, the observed gas should cloud head it to our black hole. Oh well, black holes pass. Then Dennis had his hand up, so he wants to say some more. Hello.
Yeah,
Dennis.
The physicists of today are so closely tied to the ideas of today that even if you could, for example, develop an inertial propulsion device, which means that momentum is not conserved, they will not even look at it. They're not interested because they know it can't exist, even though you can show them that it does exist. For example, in 2015, then Boeing supervisor Mike Gamble gave a Boeing-approved talk, which you can get a video disc of from Tesla Tech. Gave a Boeing-approved talk showing that the Boeing scientists and engineers had thrown out conservation of momentum, and they had developed a space drive type thing, which they used to keep their smaller satellites in orbit instead of using a rocket fuel or something to keep them in orbit. They used an inertial propulsion device to keep them in orbit. This means that momentum is not conserved. Well, as far as they're concerned, that's crazy. They aren't even going to look at it. They aren't interested. Go away. Yet they claim they have an open mind and they're true scientists.
Yeah. I think I remember reading things about that, and it's difficult to understand somebody's claim when it goes against you've sort of been taught physics. So I looked at there's a book called Voodoo Science. There's a skeptic sort of like debunking people who make claims for things like perpetual motion machines. And there was one person who claimed to have a perpetual motion machine. And so, which means to some extent, you've got more energy coming out of the machine than going into the machine, which would violate what most people think as possible. And the person who wrote the Voodoo book was saying the person who was saying it was a perpetual motion machine was wrong. It's just a more energy efficient machine. So it's a sort of like conflict between how two people talk about something. If the person who had the machine was saying it was a more energy efficient machine, then the debunker would have agreed that that was what the machine was doing. But because he was saying it was a perpetual motion machine, then You're discarding it as nonsense. So it's how you describe something. And if you got more energy out from a machine than what you're putting into the machine, then it's conflict to most people who've got the idea that energy in is more than energy out. So sort of problem than that. Okay. Do you want to add any more to that? No. If you finished, okay.
Oh, first.
Okay. Okay. That's that. That's it. Thank you. Thank you. Right. Remove. Right. Remove. Thank you. Bye. Cheers. Nobody else has got their hand up. Oh, James has got his hand up. Okay. Hello, James.
Hello, Roger. At the beginning of your talk today, you mentioned the fifth postulate. What is that, sir? The fifth postulate.
What, Euclid? It's the parallel postulate of Euclid.
And so the first four postulates are what? So it's a geometric postulate.
So if I can go share screen, then you can share. Is that it? Oh, that's it. It's Euclidean geometry. And if you go down for Euclidean geometry, it's non-Euclidean. It explains the difference between. If I can make the screen bigger on my end. Oh yeah. So it explains the difference between Euclidean and non-Euclidean geometry. It's the nature of parallel lines, and that's the fifth postulate in Euclidean geometry. For given points, for a given point and line, there is exactly a single line that passes through the given points in the same plane, and it never intersects. Whereas non-Euclidean geometry is different. The spherical geometry, for example, is non-Euclidean because there are lines not straight on it. Draw lines on the sphere are not straight lines, they're curved. So the properties of Euclidean geometry are shown there.
I see. So you were talking about Euclidean geometry and the postulates thereof. Okay, thank you. That's what I wanted to clarify in my mind. Thank you.
Cheers. So, modern physics from Galileo, Newton, and so forth seems to be based upon Euclidean geometry. So when they went to look for what mathematics they're going to use, it was Euclidean geometry, and that was about 300 BC. So the mathematics goes back a long way, and this mathematics was developed further. And then they came up with the idea of non-Euclidean geometry. So this is the mathematics which the physicists are using. So we move. Yeah, if I had to stage my slides, and so when our group was formed, they were the neo-Newtonians, and they were wanting to return to Newtonian physics before Einstein. So Einstein was looked upon as corrupt in physics, and you want to go back to Newtonian physics. And if you go back to Newtonian physics, as I was trying to point out, then that Newtonian physics led to this idea of the vortex theory. And the vortex theory, we distants don't seem to be talking about that much. Very rarely. You've got exceptions like Jim Carter and so forth, and Bergman. but in general, we don't seem to be talking about the vortex theory. And as far as the mainstream is concerned, they ignore it. They just treat it as only of interest for historians. And when it comes to presenting ourselves to the mainstream, we're saying we think Einstein's wrong about a lot of things, and we should return to the vortex theory. And ideally, we should agree on that, even though the mathematics for the vortex theory is very complicated and needs a lot more developing. And I think that summarizes my talk, basically. We should be aware that being anti-relativity, what we're really talking about is trying to go back to physics before Einstein as being the vortex theory. And part of the problem is that Einstein has been badly translated. He's been talking about point particles, and that's not obvious because the translations have been bad. So it's not been obvious that Einstein's physics is based upon point particles. So I think that's it. Thank you. I think I'll end it here now. I think everybody's had their say. Okay, so end of talk. Thank you. Goodbye, everyone. Thanks for your attention. Ending now. Goodbye. Bye. Bye. End stream. Bye then. End stream.